All right. The point is, though, that Daniel Valvo has brown hair, implies Daniel Valvo is a U.S. citizen. I have brown hair, I'm American citizen, I'm not going to get my passport for you. But the point is, this is true. And this should no longer be as unsettling. I hope it's not. Because even though it's true for me, Daniel Valvo, that's just because our universe is so tiny, this is a coincidence. It does happen that I have brown hair, and it does follow that I'm a U.S. citizen. It happens to happen in this case because we're just looking at Daniel Valvo. But we're not saying something about all people. This is saying something about all people. Does the difference here make sense? Talk to me, people. Talk to me. Well, I want to know how I feel about this because it's legitimately an unsettling thing. I mean, we had that in the homework, right? Where I gave you guys that one example where it was like, there's only 5 dogs in Blacksburg implies the world is round is true or something like that, right? And that's incredibly unsettling because those two facts had nothing to do with each other. But the problem is, once again, our universe was so small. We're just talking about this specific case of things, right? Whereas in order to actually see a deduction, in order to actually think about this, in order to actually think that having brown hair has anything to do with being a U.S. citizen, you have to vary your subject. You have to vary your subject to see if it works for all of them. That's what it means to have a deduction. That's what it means for brown hair to actually imply you're a U.S. citizen. It has to work for everybody, right? It does not just have to work for one person. I think that makes sense. I think so. And let's write this in big red letters. In order to say that property P of something implies property Q, you have to consider subjects in all of the domain, not just one.
I have a question.
And then once you have that, it is true that property P implies property Q. Here, Daniel Valvo has brown hair, means Daniel Valvo is a U.S. citizen. That doesn't mean anything about having brown hair implying you're a U.S. citizen. It just says Daniel Valvo having brown hair implies Daniel Valvo is a U.S. citizen because they both happen to be true facts.
Quick question.
What?
Quick question.
Yeah.
So is this meaningfully different from the case where the domain only has one element, Daniel Valvo?
You know, it kind of depends how you look at it. So you're saying like what if the statement was for all X in Daniel Valvo, if X has brown hair, that implies X is U.S. citizen. Is that what you're saying?
Yeah.
It is meaningful different because again, this is just saying something about Daniel Valvo. You know what I mean? Your universe is one data point. It's really small. This right here, if you actually want to talk about the property, right? If you want to talk about the property itself, if you want to talk about the property, oh wait, these are backwards. Oh, well, you see my point. If you want to talk about the property of being an American citizen, I'm gonna flip these. Is a U.S. citizen is a U.S. citizen. Daniel Valvo has brown hair. So the point is, if you want to talk about these properties, if you want to talk about the property of being a U.S. citizen, it implies that it also must have the property of having brown hair. If you want to say the properties imply each other, that means the subject shouldn't matter. And so the subject doesn't matter, your domain can be as general as you want it to be, all people, right? But if it works for all people, then you know what it was the property. It was the properties that are important. But if your domain has to be really tiny, if you're just looking at one specific thing, this really isn't saying anything about the properties. It's saying something more about the person itself. Does that make sense?
I mean, it does, but like it still doesn't really like chase away the idea that this isn't quite exactly implies, right? Like
Well,
it
you know what?
becomes more and more
I'll
true
give
the
you a
bigger
better
domain
example of
gets,
that.
right? But like
A better example of that would be this right here. If you say, if I have, or I'll say if X has an even number of children, then the world is round. Right? What you can write in math as, like, if you call this P of X, you call this Q of X, this is equivalent to saying for all X in people, P of X implies Q of X. And the problem is, this is true. The problem is this is true right here. And the number of children any person has does not affect the shape of the world. It turns out these are totally independent facts, right? But it's true because for any X you plug in here, right, whenever P is true, Q is going to be true. Why? Because Q is always true. Remember, P implies Q is equivalent to not P or Q. So you can write this as for all X in people, not P of X or Q of X. And since this Q of X, like the X doesn't even show up here, right? There's not even an X here. There's like a constant function, like f of X equals 1 or something like that, right? Like that function right there, it doesn't matter what X is, it's a constant. Same here, this is a constant. The world is round, it's totally independent of if you have children or not. The X doesn't even show up. But this is always true. It's basically, it's a tautology basically, right? And so this is always true no matter what the hell X is. And so what that means is you're always gonna have the or Q of X be true. But anyway, the point is this statement right here will always be true. And it has really nothing to do with X. So in this case, it's not really saying there's a dependence, but the reason for that is because there's kind of no X here. This is cheating a little bit. If you make one of your statements a tautology. But if both of your statements really do have X in them, then you really are making a deduction because you're saying that this predicate, and a predicate is really, what is it? It's just a property that's kind of disembodied from its subject. Right? This is saying if X has any even number of children, this is X has any even number of children. The properties have an even number of children. What's the subject? Doesn't matter. It's just X. We'll plug it in later. Right? So this truly is kind of studying the idea of a property. If you have a property, if you have a predicate here, it implies a predicate here. And they both truly do have something to do with X. They're not tautology. They're sometimes true, they're sometimes false, depending on what X is. Then you really do have some sort of deduction because you're saying that whenever X is property P, it's also going to have property Q. So there is kind of a dependence there, at least for whatever your domain is. I feel like I'm ranting. Is this at least interesting to people? It's a great question. It's a great question. And it's kind of like, it kind of just depends. This depends a little bit on your perspective, because all these things have strict mathematical definitions. And I'm kind of trying to give you a little bit of intuition. I'm trying to kind of give you a little bit of intuition for it and how mathematicians like to think about it. But the point is, if you have a different perspective, you'll think about it differently. And that's totally fine, right? As long as we agree on the underlying truth table and all that definitions, we can still do math together. So whether or not you think about this as truly being a deduction, or whether or not you just think about this as more of just an if-then function applied to a larger domain, right? Doesn't matter. The point is a general universal conditional statement saying that for every x in a domain, whenever the hypothesis predicate happens, then the conclusion predicate must happen. All right. And those are some of the most important. That's arguably the most important statement in math, because everything we do from now on will basically be universal statements. We'll be trying to prove things about, because remember, in math, we're trying to link statements. So like we're trying to prove things about all even numbers. We're trying to prove that if x is an even number, that x is some other property. If x is multiple of 4, x is some other property. If x is a prime number, we know this. If x is like, it's all going to be about that. Any questions?
So one more thing is, what about the case where every x in the domain is going to evaluate false and...
So then you're always vacuously true.
Right. Okay.
That's another good question. So let's say we had for all x in people, x is a dog implies x is a doctor. This is true. Because for all x in people, right, x being a dog is going to be false. It's never going to be true. So this statement's always going to be vacuously true. You can prove, you can kind of make a proof. You can say, let x in people, then x is a dog equals false. So x is a dog implies x is a doctor is going to be true. All right, that would kind of be your proof. The point is you're proving for any particular person, this is true, so for every person it's true. The point is, though, this is kind of like the whole pigs fly thing again. It's like, you know, we said like, if pigs fly, then I'll give you $1 million kind of thing. It's like, it doesn't really matter what you say after the if pigs fly, because it's not going to happen. You know what I mean? It's kind of a meaningless statement. That's how I would think about that.
Is there like a notation for none? Like for no elements or?
For vacuously true?
No, like, you know how there's like the for all, like the upside down A, but like,
Yeah.
is there a for none?
Oh,
like
for none?
nothing?
So the way you would write for none, so if you want to say, instead of saying for all people, you would write for no people, you would say, what you'd say is you make a there exists statement and then negate it. Because if you're saying there does not exist, that means it's for none.
Okay.